So on page 8, it says you're given an equation like this, a cubic equation like this, and you know from the beginning that there is a solution to that, x equal 2. The question is how to find the rest of the solutions. This is a typical example, the typical thing which will happen if you use the Cardano method. Again, the Cardano method, that's the one which lets you find the first root of the cubic. Like I said, there's not much of the value, practical value in that method, but it's just a beautiful, but still it's a beautiful method. I like it. Most of the time you will be able to guess those roots. I'll explain you how to guess those roots, or they will be given to you up front in the questions. But after you have one root, then there is a method which is called the quotient of polynomials, which allow you to find the rest of the roots. And that's something which I would like to address right now. So normally you do like this. Let me just zoom in a little bit. Here's my polynomial I'd like to solve. It's a cubic one. I know that 2 is a solution. We can double check, by the way. If I put 2 across the equation, it should be correct numerical identity. 8, take 12, plus 4, it is 0. Yes. So it is truly a root. Doesn't matter how we found that. We have it. Now we can develop this further by doing something like this. Look at this. I can take the first element of my polynomial. Let me just zoom in here. Then look what I'm going to do. You may ask, why do I do that? I'll explain in a second why exactly I do that. Just for now, just admit it. I just enjoy it. Look what I'm going to do. I'm going to subtract the double x squared from that. Well, double x squared came from out of the blue, right? There's no any double x squared in here. So in order to keep this identity true, I have to remove it by plussing double x squared. Then I will subtract negative 4x. Negative 4x hasn't been present in here. It's negative 6x, in fact. So in fact, I have to negative double x again to make it negative 6x in order to support this identity. And then plus 4, I just copy plus 4 from what it was before. Why did I do that? Because now if I look at these two terms together, I can factor out x squared, and that will give me the expression like this. And if I look at these two terms individually, I can factor out double x, and that will give me, again, the bracket, it will give me the expression like this. Finally, here I can factor out negative 2, and that will give me, again, the bracket x take 2. So if I now take this bracket and factor out from all of these three terms, the result of that will be this. And here's my factorization. You know, probably some of you may know another method, which resembles more like a numerical division. It's a long one. It goes like this. I'll show you that as well. Here it is. You start with the polynomial like this. You write the second. You write the bracket. You write this bracket you're looking for next to it. You write the. You put this. You sort of. Oh Jesus. You make a writing like this. And then you start arguing as follows. You start arguing as follows. First, you put here x squared, and the choice for the x squared is warranted by the fact if you multiply this x squared by the bracket like this, is the expression. This x squared, well, you will end up with the x cubed in here, and that will cancel the highest x cubed in your polynomial. So you subtract. The result of the subtraction will be looking like this, right? If you subtract this polynomial, here's my minus. If I subtract this polynomial from this polynomial, that's the result of that action. Now, if I want to cancel this highest coefficient, I have to plus it with double x, because double x times this will make this polynomial. When you subtract, I don't know, something fishy is going on. When you subtract double x squared, it disappears. Negative 6. That's nice. Negative 6x plus 4x gives you negative double x. And final term, you put in here negative 2, which if you multiply across this polynomial, it will be negative double x plus 4. And if you subtract this, it will be 0. This is another way how we can do that, but this is a longer way. Not only, and it's a more spacious way, it takes more space, because if you do it in the time stress environment, you won't be doing any of these extra markings. This was only explanation for the explanation purposes. You won't be doing any of that. You will be just picking up the terms by artificially building this bracket, and then you can factorize straight away like this. It's a very efficient method. If you do it a few times, and I encourage you to do that, you will realize how quick and great this method is. So if I want to finish the question what the roots of this polynomial are, all I have to do now, because if I equate this to 0, it means that I equate this product to 0. One of the brackets will give me the known solution. The other bracket will give me another 2 solutions. And again, I can use the formulae for the solution of the quadratic equation. I can use the half formula again, because my b here, again, even integer. That will give me a shorter computation. It will give me a shorter computation. So here's the other 2 solutions. Negative half b, it's negative 1. And the rest of it like this. So the first solution is 2. And the other 2 are like this.